Hi, Joel, and other class members. Your question's great, and I hope other people looked at it. We start to get kind of lazy when we're finding the critical values, especially here z sub alpha over 2. And I wanted to show you in addition to respond. And I know that you've already stated that you've figured it out, and you have to have the confidence interval percentage. Yeah, you do. So the confidence interval or confidence level will be something like 90, 99%, 95%. And those are our most common ones, and you've probably gotten used to using the common ones. So I'm going to illustrate with something that's not common. But let me first point out to all class members why we're probably very fast with the common ones. First of all, on our tables, when we go down to special cutoff values, for example, this one you can see it's showing up right here between um, a little bit over 5%, a little bit under 5%. So that there's an asterisk there, and that is telling us the area when 5%, the cutoff score when 5% is the area on the left. Okay, and obviously it's negative. Uh, Similarly here, there's an asterisk right between, and that's telling us when it's half a percent what the cutoff value is, because those are important because they come up often. Also, what comes up often are all of these confidence intervals: 90%, 95%, 99%. So we've already, in the bottom right hand corner of the second page of the z-scores, we've already calculated those common ones. And if that wasn't enough and didn't start to make us too lazy, we start to get even more lazy when we look at the review card. And let me scroll up here on the review card. We've got a bunch of these common confidence interval values, confidence levels, also stated over here. Let's see, this one is the second page. And, if it's a right tail test or left tail test, or if it's a two tail test, which is going to correspond to our values up there. Let me scoot back and I can make that more clear. So a confidence interval obviously has two tails, and we use the positive critical value of 1.645 for 90% and so on. And you'll notice down here that when you're doing a two-tailed hypothesis test that's using the normal distribution, we've got the same thing going on here, but it states it instead of by confidence level, like 90%, 95, 99, it states it by its complement, which is the significance level. And I was starting to state that in my answer. Your calculator can do all the work for you if that's what you're using. You can put in 1 minus 0.92 and it'll figure out that that's 0.08. You can even put in 0.92, which will tell you that that's the middle of your confidence level. And then you have to split the tail and add it on so that when you use the inverse norm function, it will draw that area from the left, and it won't just draw the 92%, but it'll scoot that middle section of where your confidence level lies over an additional 4% because your tail would be another 4%. So let me demonstrate this with StatCrunch, and if you'll just pause with me for a second while I do that. Okay, in StatCrunch, and the reason I'm using this instead of the TI-83, even though I just told you how to do it, is in StatCrunch you can see the distribution almost real time. So I'm going to go in through the normal distribution, so those are z-scores, one sample with summary data. Oh, I apologize, that's overkill. Let me see if it, as soon as that finishes, I'm going to close it. I'm just going to go ahead and use the calculator. So that we could have done the whole confidence interval for a one sample. You actually could have used that and used the two sample and done that whole thing. Especially if you're doing the proportions, like in chapter 9, proportions, two sample, and then with summary. And then it will, let me see if I can get this to stop moving. It will ask you all the appropriate things, but you need to remember yourself that the requirements are met, that they're from independent samples that were sampled with simple random sampling, you need to remember that the number of successes is greater than 5 and the number of failures is greater than 5. But once those requirements are met, that's a really quick way to run the whole test. I actually just wanted to show you the directly related to what you'd asked. So if I go down to calculators, okay, under stat, I can go to the normal distribution and put in my mean and standard deviation. Well, I'm going to leave those the same, 0 and 1, because that is, even though the label here says x, that is still the standard normal distribution. The only time it's not standard normal is if those are anything other than 0 and 1. So even though it says x right here, that's really z in this case because we're using 0 and 1 for our standard, 0 and 1 for our mean and standard deviation, which is what sets aside the standard normal distribution. So then if I want to do something like have 92% area on the left, I could compute that, but it's not going to be the right thing for the confidence interval because that's saying it's got 92% from the left to this cutoff value, which is going to be the z-score 1.41. What I really mean to do is I mean to add 8% or add 4% to this, half of my difference. Because if your confidence level is 92%, then your complement to that is 8%. And that's what we call alpha, the test level, or level of significance. And you're going to split that in half. Now, this cannot dynamically do this like the calculator can, so I will go and show you the calculator, but it does show me a picture, and that's what I like about it. So let's see, let's scoot all that red zone that we had over 4% and put in 0.98%. Ah, sorry, crazy. 0.96, I mean. 92% plus 4%. And I hit compute, and there it goes. And actually, that mistake I just made is a perfect mistake, because I was going to put in 0.98, which would not have been what we were talking about when I said that we were going to do a 92% confidence level. So if I want to make sure I don't make a mistake in this addition, and then, scoot it over too much, if I would have scooted over to 98%, I would have actually been scooting over from 92 an additional 6%. And I meant to go to 96. Then I can use the calculator. I'm going to put the calculator up here. Okay, I'll make room for it over here. So on the calculator, what we do is we go second vars, which gives us our distribution choices, normal, CDF, inverse norm. These are the ones for standard normal distribution, or for any others if you change the default settings. And then you hit enter inverse norm. I can say from 0.92 plus whatever 0.08, which is the complement. Now that's pretty easy to, just visually calculate the complement, or mentally calculate the complement, divided by 2, and then hit enter. What some people like to do, though, is they like to just find the left one and then realize that that's the negative copy because you're working on the left, and then they just change the sign or drop the sign. So to demonstrate that, here's inverse norm by doing second vars, going down to 3, and just say 1, let me see, if we want to let it do all the work. And that's what I'm trying to demonstrate here, is that the calculator can do intermediate calculations inside the functions that it's about to run. So let's do 1 minus 0.92. Now this is all in parentheses because I want it to follow this specific order of operation. I want it to find the complement for me because I'm just too lazy to figure out that that's 8%, or 0.08. And then divided by 2. And then I'm going to close the function and hit enter. Sorry, one extra parenthesis there. Let me just do that again. And it's going to give me the negative one. See, here's the 1.7506. Let me get StatCrunch back up here so we can see that that's what we had. 1.7506. And the difference is just the fact that it's negative. I'm on the left tail. And watch what would have happened if I would have only put alpha over 2 in here. In other words, 4%. I'm having a great time on this video. Thank you very much, with power running out and hitting comma instead of decimal. Anyway, there I am, negative 1.75. So what do? We just recognize where we're located, and we make the change in our mind, and we drop that symbol, since we're looking for, like you asked in the very first problem, just the critical value, z sub alpha over 2. Let me draw your attention before I leave to one more thing, that if you use a multimedia library, you can get a lot of help for how to use the calculator and just generally how to do these problems. There's section lecture videos, and they're also divided up by objective types and by homework problems. So I was watching this section lecture video just to see what it was like. I haven't seen it in a while. And they have a good explanation of it here. She goes through
So the
several
problem
examples.
starts with, use the sample data given in the table to construct a 90% confidence interval estimate of the difference between the two population proportions.
Of those very common
So what we
values.
need here is just the fact that it's a 90%.
So she's using the 90%. I mean, that's what we keep seeing happen. In fact, this is how she demonstrates through it. So I don't know if you can see here, but she's as in her explanation, she said our confidence level is 90%, therefore z sub alpha over 2 is 1.645. You know, if we use the common ones, we get so lazy, and we just, we either just look them up here for our common critical values, or we might look them up in the bottom of the chart for our common critical values. But you do need to know how to find them generally, because not all confidence intervals are going to be 90, 95, and 99. And we want you to have a better understanding. All right, hopefully that helps.